Imagine you're floating alone in space. No sound, no warning, and in front of you is a black hole. At first, it looks almost empty, just darkness. But that darkness is hiding something terrifying. A place where gravity becomes so powerful that not even light can escape. And somehow, you're falling toward it. So what happens next? As you get closer, the black hole doesn't simply look bigger. The entire universe begins to look strange. Stars behind the black hole appear distorted. Their light bends around the object like it's being dragged through invisible glass. This is called gravitational lensing. The black hole isn't just pulling matter toward it, it's bending space-time itself. And you're getting closer, much closer. Now something even stranger happens. Time. For you, your watch appears to tick normally. 1 second, then another, then another. But someone watching you from far away would see something completely different. As you approach the black hole, your movements would appear to slow down. And the closer you get, the slower you seem to become. From their perspective, you appear to approach the black hole's event horizon and almost freeze there. But from your own perspective, you keep falling. You don't feel time stopping. You continue forward. And there is no magical wall waiting at the horizon. You simply cross it. The event horizon is the point of no return. Cross it, and escaping becomes impossible. Not because your spaceship suddenly stops working, not because there's an invisible barrier, but because space-time itself has become curved so intensely that every possible future path leads deeper into the black hole. Even light cannot turn around, and neither can you. For a distant observer, the black hole may seem to hide you forever, but for you, the journey continues into somewhere no human has ever visited. And now, gravity becomes truly terrifying. The gravitational force acting on your feet can become dramatically stronger than the force acting on your head. That difference creates enormous tidal forces. You would be stretched along the direction of the black hole while being compressed from the sides. Physicists call this phenomenon spaghettification. And the name sounds almost funny, but the physics is anything but funny. Near a small black hole, these tidal forces can become extreme before you even reach the event horizon. A supermassive black hole is different. Its event horizon can be enormous. You could potentially cross it without immediately noticing anything unusual. But that doesn't mean you're safe. It only means the worst may be waiting deeper inside. As you fall deeper, the outside universe becomes increasingly distorted. Light from distant stars can be bent into strange arcs around you. The sky no longer looks normal. Directions lose their familiar meaning. And the black hole ahead isn't simply a hole in space. It's a region where our current understanding of gravity reaches its limits. At the center, according to classical general relativity, there is something called a singularity, a place where the equations predict extreme conditions. But here's the problem. We don't actually know what happens there, because general relativity and quantum mechanics don't yet fit together into a complete theory of quantum gravity. So the final chapter of your journey is still a mystery. Would you see absolute darkness? Not exactly. The universe around you could become incredibly distorted. Light could wrap around the black hole. Objects behind it could appear in unexpected places. The sky could become a warped cosmic panorama. And depending on the black hole and your trajectory, the visual experience could be completely unlike anything we've ever seen on Earth. But eventually, there is no turning back, no escape. No signal can return to tell anyone what happened. You have crossed a boundary beyond which information cannot reach the outside universe. And perhaps the most terrifying part isn't what we know, it's what we don't. We don't know what truly happens beyond the event horizon. We don't know whether the singularity predicted by our equations actually exists. And we don't know what a complete theory of quantum gravity will reveal. A black hole isn't simply a monster consuming everything around it. It's a natural laboratory where space, time, gravity, and the laws of physics are pushed to their absolute limits. So if you ever wondered, what would happen if you fell into a black hole? The honest answer is, we don't know everything. But one thing is certain. Once you cross the event horizon, the universe has no way to bring you back. This is NexusReality SR, and the deeper we look into the universe, the stranger reality becomes.